Hello and welcome back. So in the last video I briefly explained limits that tend to infinity, and so now let's do a couple problems where the limits do tend to infinity. But before we can do any of those problems, there's one thing that you need to know, and that is the limit as x tends to infinity of any rational function that has a constant in the numerator and has an x, or the variable, whatever the variable is, to any exponent, so let me call that n, is always going to be 0. And you saw an example in the last video in which we had 1 over x, and you can see how that works, because 1 over x is, you have 1 over 1, 1 over 2, and it just keeps getting smaller and smaller and smaller and smaller, and it tends towards 0. But that works for anything. If we had 3 over x squared, for example, that is 3 over 1, 3 over 4, 3 over 9, and so on, and it just keeps getting smaller and smaller and smaller, and also tends towards 0. So this is the main idea that you need to know with any of these problems that tend towards infinity. So let me erase this, and let's do a couple problems that are like this. So let's say we had lim oops we had the limit as x tends to infinity of x plus 1 over x squared plus 3. And so what you need to do in a problem like this is you find the highest exponent in the denominator, which in this case is x squared, and you divide every single term in this rational equation by the highest exponent in the denominator. So in this problem, this would equal limit as x tends to infinity x over x squared, and all I'm doing, I'm just dividing every single term that there is by the highest exponent in the denominator. So it's x over x squared plus 1 over x squared, and that's all over x squared over x squared plus 3 over x squared. So now I can simplify this, and this equals x over x squared simplifies to 1 over x. 1 over x squared doesn't simplify anymore, so that's just 1 over x squared. And that's all over x squared is 1. And 3 over x squared, you can't simplify that anymore, so it's 3 over x squared. And so this is what you're left with. I should have actually written the limit as x goes to infinity, because we haven't done anything. We haven't substituted anything yet. Or we're not really going to substitute anything, but I don't have any space now. So, but now that you know this rule right here, that any constant over x to any power goes to 0, you can change 1 over x. You know the limit as 1 over x is 0. The limit of 1 over x squared is also 0, and that's all over 1. The limit as any x goes to anything of a constant is going to be that constant, so that's still going to be 1. Because there's no x here going anywhere, it's not changing this value. So it's 1 plus, and 3 over x squared follows the same rule over here, it goes to 0. So we end up getting 0 over 1, and that is 0. So, that's the basic idea of doing these. Find the highest x in the denominator, the highest power of x in the denominator. In this case, it was x squared. I'm going to do one more where it's a different one. And divide each term by it, and then simplify it, and then find the limit of each one separately, and then put them all together, and then you get your final answer. So let's do one more of these. That's a little more complicated. So let's say we had the limit as x tends to infinity of negative 2x cubed minus 2x plus 3. And this is all over 3x cubed plus 3x squared minus 5x. So we look for the highest exponent of, the biggest exponent in the denominator, which is x cubed in this case. And we divide every single term by x cubed, not 3x cubed, just x cubed. So let's do that. So this equals the limit as x tends to infinity of negative 2x cubed over x cubed minus 2x over x cubed plus 3 over x cubed. And then this is all over 3x cubed over x cubed plus 3x squared over x cubed minus 5x over x cubed. And now we can simplify all of this down. This all simplifies to the limit as x tends to infinity of negative 2x cubed over x cubed is negative 2. Minus 2x over x cubed is minus 2 over x squared. Plus 3x over x cubed, you can't simplify that anymore, so that's still 3 over x cubed. And this is all over 3x cubed over x cubed is 3. 3x squared over x cubed is 3 over x. And minus 5x over x cubed is minus 5 over x squared. And now we can do the same thing again, the rule that was written up here a second ago. Negative 2 still stays the same, because the limit, there's no x over here, so it doesn't matter what the limit tends to, it'll just remain negative 2. We know that anything over x to any power is always tends to 0, so that'll be minus 0. And the same thing for this one, so that's plus 0. And then 3 remains the same, so this is over 3. And this tends to 0, because it's over an x, a constant over an x, so it's plus 0. And then this is minus, this is also a constant over x, the same thing, minus 0. And so we end up with the final answer of negative 2 over 3. In general, you just really have to remember that you have to divide each term by the highest exponent in the denominator. And then you can simplify it out and then do each limit separately and then put them all together, and then you'll get your answer by doing that. So if you have any questions, you can email me at utamatchboxman@gmail.com, and keep watching.